Not an earthquake, but a mega earthquake could happen in Japan. It's scarier, bigger, and more destructive than ordinary tremors. However, the problem is that it will occur underwater, which means it will trigger a giant tsunami 100 feet high. A column of water nearly as high as a 10-story building will collapse on coastal cities, wiping out hundreds of houses. The water flow can destroy everything in its path like a bowling ball that knocks down pins. And then another wave may come, and another one. Anyone who is at risk should be on their guard. How to survive? You'll find out later in this video. But first, let's find out what a mega earthquake is. This is an earthquake with a magnitude 9 or more. This is a very rare phenomenon, and it depends not on the power of the shock, but on the length of the fault where it occurs. The longer the fault, the stronger the earthquake. But what are these faults? These are cracks in the rocks of the Earth's crust that move relative to each other. Imagine a large puzzle where every detail is a giant tectonic plate. When one part of the puzzle moves away from another or when they collide, that's when earthquakes begin. If the fault between the parts is long, then the magnitude of the earthquake is great. The largest mega earthquake ever recorded occurred on May 22, 1960, in Chile. The fault was almost 1,000 miles long. It's almost half the way between Chicago and Los Angeles. And now, a similar mega earthquake can happen, underwater. That's how it all started. Last year, on August 8th, at 4:42 p.m., an earthquake with a magnitude of 7.1 occurred in southern Japan. The tremors appeared off the coast of the mainland island of Kyushu. Everyone was terrified as they expected a large tsunami to appear. But fortunately, they faced only a small wave. It collapsed on the shore, but didn't destroy buildings. About 15 people got hurt, which is sad, of course. But it could have been worse. It seemed that the disaster had passed. The residents breathed a sigh of relief. However, after that, the Japan Meteorological Agency sent a warning about a possible mega earthquake that could be incredibly devastating. A previous earthquake of 7.1 magnitude could be a harbinger of an impending catastrophe, a disaster that could affect 250,000 people. As soon as people heard this, they ran to buy groceries. Increased demand and a slight panic led to shortages of rice and several other basic products. People were stocking up on food and preparing for the worst. But a week later, the Japan Meteorological Agency canceled the warning. It turned out that the small tsunami on Kyushu Island was not a harbinger. No one knows whether a mega earthquake and tsunami will happen in this region, but the chances are very high. To understand the nature of this danger, we need to dive underwater in a place called the Nankai Trough. It is a 500-mile-long underwater fault that runs almost parallel to the Pacific coast of Japan. This is where the two giant sections of the Earth's crust meet, the Philippine Sea Plate and the Eurasian Plate. And the Philippine Plate is subducting and slowly slipping under the Eurasian Plate, on which Japan is partly located. During this movement, the plates get stuck, accumulating energy. Afterward, when they move and align again, they release a powerful burst of energy. And this energy is capable of causing one of the most powerful earthquakes in the world. Experts report that the probability of a mega earthquake and a tsunami is about 80%. Over the past 1,400 years, mega earthquakes have occurred every 100 to 200 years in this region. The last time this happened in Japan was in 1946. The entire country felt a powerful tremor that destroyed 36,000 houses in the southern part of Honshu Island. Every year, the probability of a repeat of this disaster increases by 1%. And do you know how many years have passed? 79. According to experts, a mega earthquake with a magnitude of 8 to 9 can trigger a tsunami that will flood small islands off the coast of Japan. And areas with large populations on the islands of Honshu and Shikoku can be flooded in minutes. Hundreds of thousands of people are at risk. It can be billions and even trillions of dollars worth of damage. According to some reports, about 530,000 people may lose their homes. To save lives, the country needs to carry out a large-scale evacuation. But the problem is that no one knows the exact date. In general, no one in the world can predict in advance when the next big earthquake will occur. In the case of the Nankai Trough, it can happen in a few days, or a few years, or even centuries. So, what should people do? Prepare. Japan has been experiencing earthquakes for a long time, so the country has learned to survive a disaster with minimal losses. Almost every building in Japan is equipped with dampers, which are devices that suppress any vibrations and make houses more resistant to shaking. In addition, on the shores of Japan, residents have built long and high shields that don't allow powerful waves to break through to land. Japan also has an advanced earthquake warning system. It's impossible to predict powerful seismic activity in a few days or weeks, but it's possible to detect small tremors that may portend an impending earthquake. Special devices monitor seismic signals and transmit the data to certain programs. Then, they evaluate the magnitude and intensity of the tremors and send warnings to people's phones. This can save seconds and even minutes for locals to reach the nearest shelter in time. These systems are also used to slow down the speed of trains, to stop work at factories, hospitals, and office buildings. It's much safer for a train driver to slow down during an earthquake than to rush forward at full speed. But what if you're on the street and you can't hear your phone messages? How to act in case of disaster? This applies not only to Japan, but also to any place where a tsunami or earthquake may occur. To survive a tsunami, you need to prepare for it long before a big wave hits. It's very important to have good relations with neighbors. Be friendly with them, help them, and treat them well. In times of trouble or disaster, it's great to have people with whom you have a good relationship. They can help you get out of a difficult situation, and you can also help them. Be kind and compassionate to people. This way, it's much easier to survive any disaster. Prepare a backpack with necessities in advance. These are a first aid kit, canned food, flashlights, a battery-powered radio, and bottled water. All this will not only save your life, but will also help other people in trouble. So if you feel an earthquake start, immediately run for cover. If you're at home, try to stand against a wall closest to the center of the building, or crawl under heavy furniture that stands firmly on the floor, such as a desk or a regular table. Stay away from windows and front doors, and never use an elevator. If you're on the street, don't come close to power lines and any objects that may fall. During a tsunami, you may need to get as high as possible to avoid getting swallowed by water. Stay as far away from the shore as you can, and don't go down until you're sure it's safe. But how can you find out about an approaching wave if you haven't received the warning? When a tsunami approaches the shore, you will hear a roar similar to the rumble of a passing train or plane. If there's no elevation nearby, then try to get to the upper floors. It must be at least the third floor, but it has to be a building that can resist a tsunami, such as a massive house made of concrete. If there are no such high buildings nearby, try to climb a massive tree. When the disaster is over, look around and find those you can help. Listen to messages from rescuers via radio or TV. If all is well, then you can deal with the consequences. Yes, there's a lot of work ahead, but you've survived and helped others survive. And that's the most important thing.
Hey, can you lift a truck with your hands? No? Shocker. But let me introduce you to nature's original strongman, the ocean, which casually tossed 700-ton boulders around like they were pebbles during a megatsunami that hit Africa thousands of years ago. This wasn't just a bad day at the beach. This megatsunami was so powerful, it made the 2004 Indonesian and 2011 Japanese tsunamis look like kiddie pool splashes. Now, to give you an idea of how terrifying regular tsunamis already are, the Japan tsunami produced waves 133 feet tall. The Indian Ocean tsunami was slightly smaller, but it took over 200,000 lives across many countries. Now imagine something way worse. You see, for a long time, scientists thought waves that big were just science fiction. But then they found these enormous boulders, massive chunks of rock, flung far inland, and did the math. It turns out only waves around 800 feet tall could have pulled off that kind of rocky vandalism. And the culprit? A volcano that literally fell apart into the ocean and triggered one of the most powerful tsunamis Earth has ever seen. Usually, tsunamis are blamed on underwater earthquakes, tectonic plates getting into slap fights. But volcanoes? Oh, they've got tsunami potential too. In 1883, for example, a volcano in Indonesia named Krakatoa erupted for 6 months non-stop until it exploded, and the explosion was heard all the way in Australia. This triggered many tsunamis, some almost 100 feet tall. Still, that was more like a toe dip compared to the full cannonball from the Megatsunami. Back in ancient times, the volcano that crumbled during the Megatsunami was huge, and it didn't just fall apart. It lost a chunk that was 10 times the size of Mount Everest. 10 Mount Everests. It was like the Earth wanted to see what would happen if we threw a mountain into the ocean just for fun. It was so massive that when the entire side of the volcano belly flopped into the Atlantic, it created waves that could cover the Statue of Liberty 3 times. It also destroyed an island more than 30 miles away. The volcano behind this real-life Michael Bay scene was called Fogo, located on, you guessed it, Fogo Island. This island is basically just a whole single volcano that rose from the sea thanks to a magma hotspot, a place in the ocean where a lot of magma escapes and erupts like an underwater volcano. Over time, this magma cooled and stacked up like pancakes until, voila, after 7 major eruptions, the island popped out of the ocean like it was playing peekaboo. Surprise, it's a volcano. But Fogo's dramatic entrance was also a ticking time bomb. You see, the more a volcano grows, the heavier it gets, and if there's not enough magma inside it to support it, the whole thing can just collapse. Sometimes it doesn't take much. A minor earthquake, some erosion, or just a poor foundation made of soft sediment can trigger a collapse. It's like a really tall guy trying to balance over a bunch of marbles. Fogo had all the bad luck ingredients: too tall, too heavy, and built on squishy ground. And it gets worse. As the volcano grows heavier, it starts squishing the magma underneath. That lava can't rise, so it just simmers down there, slowly thickening like soup left on a burner for too long. Gases build up, pressure increases, and eventually, kaboom! It's the volcanic version of eating too many burritos and then trying to hold in a sneeze. This massive pressure and imbalance can trigger what's called a flank collapse, which is science speak for oops, half the volcano just fell into the ocean. That's what happened with Fogo. Most of the volcanic islands that form this way are long gone, but Fogo is still very much alive and kicking. In fact, it last erupted in 2014, and considering that it goes off every 20 years, maybe don't travel to Fogo Island in around 2034. For the longest time, scientists believe only big, bulky volcanic islands could collapse like this. But new research says that even smaller, skinnier guys, like the Danny DeVitos of the island world, aren't safe either. The thing is that small volcanic islands only seem stable because of their small mass. It's like Danny DeVito and Arnold Schwarzenegger both slipping on the ice. Arnie's fall might cause more chaos, but Danny can still go flying. And those little collapses? Yes, they matter. Take Santa Maria, a tiny island that's about 170 times smaller than Hawaii. It has collapsed multiple times, not because it wanted to, but because it's basically standing on soggy breadcrumbs. Its foundation is loose marine sediment, and to make things worse, it's sitting right next to the East Azores Fault, where 3 tectonic plates meet up for daily slap fights. This fault is responsible for many earthquakes and even some tsunamis that happened in Lisbon in the past, so you can imagine what it's like living right above it. Every time the volcano in Santa Maria erupts and grows, it also sinks. But when a chunk collapses, it bounces back up like a buoy. This seamount to island again roller coaster means that Santa Maria has popped in and out of the ocean like a submarine playing peekaboo. And with every peak comes a potential tsunami. Another volcano with similar trust issues is Pacaya, located in Guatemala. Between 2011 and 2013, scientists spotted strange movements in the soil, tiny shifts that suggested something underneath was getting restless. Sure enough, in 2014, Pacaya erupted. Luckily, it didn't collapse, but that risk still looms, especially if magma gets trapped in it like it did with Fogo. The consequences could be explosive, literally. In fact, about 1,000 years ago, Pacaya experienced a collapse that sent debris avalanches more than 15 miles away. Since then, it's rebuilt itself like a fiery phoenix, but it could still crumble again. That's why volcanologists obsess over the tiniest wobbles. It's not paranoia if the mountain really might fall. Now you might be thinking here, okay, but that was the past. Surely that kind of ridiculous megatsunami collapse can't happen again, right? Well, welcome to the 21st century. Islands like Hawaii, La Palma in Spain, and various parts of the Caribbean are sitting on the same kind of geological whoopee cushions. All it takes is the right combo: loose foundation, steep slopes, maybe some trapped magma, and boom, flank collapse. In fact, it's already happened recently. In 2018, Anak Krakatau, the volcanic baby of the infamous Krakatoa, lost a big chunk of itself during an eruption. It caused a tsunami, but it was more awkward than devastating, like a volcano losing its pants on stage. Embarrassing, but survivable. But that's just amateur hour compared to history's real showstoppers. Ritter Island's 1888 collapse was so intense that the island literally got shorter. It went from being more than 2,000 feet tall to a mere 460 feet. But the record holder is the legendary Latua Bay megasplash from 1958, where a 7.8 magnitude earthquake triggered a massive landslide that sent a wave taller than the Empire State Building roaring through Alaska at highway speeds. Strangely enough, only 5 people lost their lives here, but on the other hand, the destruction path it left behind can still be seen today, all the way from space. Melting glaciers and ice caps can make volcanoes collapse too. When they melt, there's a sudden decrease in pressure on Earth's crust that can destabilize entire volcanoes. It's called isostatic rebound. It's like suddenly yanking a chair out from under someone who's been sitting still for centuries. Whoops. Also, here's something you probably never thought you'd worry about on your island getaway. Some volcanic islands grow outward as lava pours into the sea, creating unstable platforms known as lava deltas. These deltas can collapse without warning, taking newly formed land, and sometimes tourists too, right back into the ocean. No pressure though, just thought, maybe you want to stay off steaming new land. So yeah, next time you're lounging on a beachy volcanic island thinking, wow, this place is paradise, just remember, it might also be a ticking geological time bomb with a flair for the dramatic. From ancient mountain-sized cannonballs to surprise lava deltas, volcanoes have a history of keeping things spicy. July 17, 1998. It started like a usual quiet evening in the villages along the north coast of Papua New Guinea. Then, at 5:49 p.m., the ground shook violently. Suddenly, a 7.0 magnitude earthquake struck. It sent shockwaves through the region. Walls cracked, homes trembled, and the earth beneath the villagers' feet shifted and twisted. It lasted for 19 seconds, with a depth of 19 miles, and seemed like a typical earthquake. And while it caused some damage, this wasn't the kind of destruction that screamed doom. So, people were tricked. They thought it was over. They didn't know that the worst was still coming. Then some villagers noticed mysterious lights. It began with a flash of red light along the horizon, a streak that looked like fire. It appeared shortly after the initial earthquake, stretching across the northern sky above the ocean. It flared brilliantly, then vanished in an instant. What could it have been? People started speculating whether it's a warning about something or just sunlight reflecting strangely. But just as it disappeared, it was followed by a loud booming sound from the sea. No one knew what that meant, and some villagers went to the beach, curious to scan the views. What they noticed there chilled them to their core. The ocean looked wrong. The water wasn't calm. It churned, bubbled, and boiled in an eerie, unnatural way. That's when they saw it. A massive wave building in the distance, rushing toward them with terrifying speed. Panic spread like wildfire. People climbed trees, pushed boats into the lagoon, hoping to escape the approaching monster. Unfortunately, it was too late. The first wave hit with unimaginable force and swept away entire villages in an instant. The debris was scattered around, trees were uprooted, buildings were displaced up to 160 to 200 feet inland. Even decades later, some of these affected villages can't be accessed by roads. At the same time, another strange phenomenon emerged. Many people described a red glow at the crest of the tsunami, as though the wave carried fire in its peak. They described an eerie glow as the wave approached the shoreline, a deep and unearthly hue, visible even from far-off places like Itape. And this was only the beginning. 2 more waves followed in quick succession. The second one was the most horrifying, from 33 to almost 50 feet high. By the time the ocean finally receded, the coastline was unrecognizable. After the waves had ravaged everything, leaving villages in ruins, the sky put on one final display. Survivors described a yellow or yellow-red glow illuminating the sky over the ocean. One man who survived by climbing up a tree saw the glow lingering over the horizon, stretching toward the direction of Arap and Itape. At Malol, the Sisters of the Mission looked out to the sea and were stunned by the surreal calm of the golden water. It was still as glass and lit by this unearthly glow. The glow was so vivid, it lit up the entire devastated landscape. Luckily, this allowed survivors to begin searching for their missing loved ones. A lot of people believe these lights were supernatural, an omen of sorts. This event ended up being catastrophic, sudden, and unpredictable. The Royal Australian Air Force responded immediately, sending in planes with relief supplies. People started an investigation. What exactly caused this disaster? Turns out, this tsunami wasn't like most others. Tsunami waves are very different from regular ones. We usually imagine huge breaking waves next to the beach. But they might first look like the water is rushing away from the shore. Stay vigilant because this is a warning sign. The water will come back very quickly and rise like a massive tide, often with devastating force. Rarely they come alone. They often arrive in a series, destroying everything along the coastline. They happen when a large amount of water in the ocean or big lake gets suddenly pushed out of place. The main causes are usually earthquakes, which happen when the Earth's tectonic plates shift suddenly under the ocean. They start lifting or lowering the seafloor, and this pushes the water above it, causing huge waves. This tsunami in Papua New Guinea was completely different though. At first, scientists thought that it was caused by the Australian and Pacific tectonic plates slipping against each other. But it turned out that the earthquake itself wasn't the problem. It really was pretty small. However, it had triggered a massive underwater landslide. When the seabed shifted, it pushed away an insane volume of water. The waves reached almost 50 feet high, like a 4-story building. That's how we realized that even small earthquakes can actually cause massive tsunamis via underwater landslides. What's even worse is that tsunamis like this can happen with little or no warning, simply because the earthquake alarms don't go off. But what about that bubbling and boiling of water that people saw? Turns out, this was the release of underwater gases. Beneath the ocean floor, there are pockets of gas trapped in the sediments. For example, methane, which is often found in oil and gas fields, or hydrogen sulfide, a gas that smells like rotten eggs. During the earthquake, the seabed probably cracked or shifted, releasing these gases into the water. This caused bubbling or boiling, The water might have heated in some areas. People mentioned that the waves felt hot and even stung their skin. The chemicals in it most likely made things even worse, irritating their skin. These gas eruptions might also have played a role in making the tsunami stronger. Maybe they were the ones that loosened the sediments that caused the underwater landslide, or pushed the water up when the gas escaped. It's like shaking up a bottle of soda. If the pressure releases suddenly, it causes a huge reaction. But what about the strange lights? Well, that's more complicated. There's a phenomenon called earthquake lights. They happen all around the world, flashes, glows, or aurora-like effects. Although they're usually white, bluish, or even multicolored, sometimes these lights last seconds, sometimes up to tens of minutes, at any point in an earthquake. If we go by their description, then the first red flash could have happened because of electricity. Earth's crust is full of quartz and similar stuff that can release electricity under pressure. When the earthquake shook the ground, all that electricity traveled up into the air. Gases from before could have helped here. They could ignite or interact with charged particles in the air, making the lights even brighter. As the wave continued to churn up sand, rocks, and debris, the intense pressure and movement could have released more sparks. This could cause the fire-like lights at the wave's crest that people noticed. Finally, the yellow light could have been all these electricized gases rising into the atmosphere. Methane and other gases interacted with Earth's magnetic field and created something like aurora borealis. But these are all speculations. The most heartbreaking part of the story is that tragedy in Papua New Guinea was preventable. Scientists knew the tsunami was coming, though it arrived earlier than they expected. The first wave struck between 10 and 25 minutes after the earthquake, about 5 minutes earlier than models showed. That means that it started somewhere close to the shore. The reason no one evacuated in time was simple. Local people didn't have a tsunami warning system or even enough knowledge about tsunamis to understand that an earthquake might lead to one, or why the water was acting weird. Things like that haven't happened in Papua New Guinea in over 60 years. But this was a wake-up call. From this immense tragedy came lessons and resilience. A year after the disaster, all the surviving locals watched a documentary that explained what had happened and taught them what to do if it ever happened again. This effort saved lives because the story did happen again. A similar earthquake and tsunami struck the nearby island of Vanuatu in November 1999. But this time, the villagers were ready. They remembered what they had seen in the film. Instead of panic, they acted quickly, and luckily, hundreds of lives were saved. Now, tsunami warning systems are everywhere in developed areas. They can send alerts to people via sirens, text messages, or broadcasts as soon as a potential tsunami is detected. A tsunami hitting major cities on or near the Mediterranean Sea and in the northeastern part of the Atlantic Ocean is not a matter of if, but when. It is scary and surreal to think that places like Cannes or Barcelona could suddenly get slammed by a huge wave, but the fact is, European coastlines are in active tectonic areas. Only about 10% of all tsunamis worldwide happen in the Mediterranean, and there have been at least 290 tsunamis in this area since 1600 before Common Era. Despite the relatively low number, this phenomenon has caused numerous devastating disasters throughout Europe's history. Back in 1755, an estimated 8.5 magnitude earthquake with an epicenter southwest of Cape St. Vincent triggered a tsunami that destroyed most of Lisbon, the capital of Portugal. About 40 minutes after the earthquake, this massive wave just slammed into the harbor in downtown, racing up the Tagus River. The phenomenon was so fast that several people on horseback had to gallop to higher ground to avoid getting carried away. And this was just the beginning of a nightmare, with 2 more terrifying waves hitting Lisbon right after. A disaster like this is similar to what we see in the Pacific Ocean several times a century, but in the Atlantic, it's very rare. This type of major tsunami is expected to happen every 3 to 5 centuries, but now it could happen tomorrow. Marseille in France, Chipion in Spain, and other cities are on the list of important locations that could be flooded soon, with a roughly 100% chance of being hit by a tsunami in the next 30 years. Statistics show that the wave will probably be more than 3 feet high. I know, it doesn't sound like much, especially since when we think about tsunamis, we imagine terrifyingly tall waves, like the one that hit Lituya Bay in Alaska. In that case, the wave was over 1,700 feet tall. But we must remember that even waves only 19 inches high can be dangerous to swimmers. Because it's not the height of the tsunami that matters, but also the flow and movement of the water. Not to mention the flooding, which can damage beaches, harbors, and streets. If the coastline has a small harbor and the waterfront is exceptionally low, like Cannes, this natural disaster might be much more dangerous. Tsunamis around 6 feet high can lift cars off the ground, while smaller waves can create walls of water traveling at 40 miles per hour. Plus, there are these smaller events that might not wreck everything, but still can cost a ton of money. For example, large sandbars that move around on the ocean floor, like sand dunes shifting in deserts. They can mess up pipelines or deep-sea cables for internet and communications, and that ends up costing businesses and governments millions of dollars. That's why organizations like UNESCO are worried about the possibility of a dangerous tsunami hitting Europe soon. So they're doing everything they can to prevent apocalyptic scenarios, like what happened in 2004 when an earthquake off the coast of Sumatra, Indonesia, caused waves over 100 feet high in coastal communities, resulting in over 200,000 lives lost. And let's not forget about 2011, when an earthquake off the coast of Tohoku, Japan, triggered a tsunami that reached about 6 miles inland and caused a major nuclear accident at a power station along the coast. Over 16,000 people lost their lives in that tragedy, and the event resulted in billions of dollars in infrastructure damage. These disasters were huge wake-up calls, and we've come a long way since 2004. We're much safer today, largely because the tsunami warning system is highly effective at quickly detecting this dangerous situation. Unlike many other natural phenomena, a tsunami can be anticipated. We may only have a few minutes to act, but if we all know what to do, many lives can be saved. And in most parts of the world, sirens are commonly used to alert people to tsunamis. To sound the siren as early as possible, initial tsunami alerts usually rely only on seismic data. First, specialists receive information about an earthquake. Seismic waves travel about 100 times faster than tsunamis, so they have enough time to analyze the data and see if the earthquake might have generated a tsunami and whether they should issue an initial tsunami alert. At U.S. warning centers, for example, scientists typically issue initial alerts within 5 minutes of an earthquake. If a tsunami is suspected, these alerts may also include information about wave arrival times, recommended actions, and potential impacts. But sounding the alarm is not enough. To save lives, coastal communities also need to be trained to respond fast and in the best way possible. That's why UNESCO produced this program called Tsunami Ready, aiming to train people living in coastal areas at risk on how to act in case of a tsunami event by the year 2030. The idea is to help communities stay safe by teaching them how to protect their livelihoods and safeguard their homes. Being recognized as Tsunami Ready by UNESCO doesn't mean a community is tsunami-proof, of course. It's more like a recognition that they have adopted all possible measures to mitigate tsunami risks. So authorities are helping communities to prepare themselves by installing evacuation signs, establishing security procedures, and creating plans to warn tourists. Like Spain, which distributed tsunami warning signs along the entire coastline, as well as signs showing evacuation routes to higher ground. And Spain better be prepared. I mean, only 7 tsunamis have hit the country since the year 365, so it's difficult to predict the effects of such an event. But they could be devastating, considering that Spanish coastal areas are so economically important. There's also a danger zone in the Averroes Fault, beneath the Abhorrent Sea. If an earthquake happens at this point, people will have only 21 minutes to escape a tsunami. UNESCO has also established 12 tsunami warning centers, which cover Europe as well. This initiative involves 5 centers located in the Mediterranean and Northeast Atlantic regions. These centers can save thousands of lives because they monitor ocean disturbances 24/7. Then, after analyzing the threat, they send out messages based on the event's potential to cause a tsunami. The intensity scale ranges from no effect to completely devastating. And by that, they understand that nearly all brick buildings could be demolished by waves, and even the most reinforced concrete structures could suffer heavy damage. Now, so far, we have mostly talked about tsunamis caused by earthquakes along converging tectonic plate boundaries. In fact, earthquakes have accounted for over 80% of tsunamis since 1900. But tsunamis can also result from landslides, volcanic eruptions, and even meteorite impacts. Experts are also worried that with the current changes in climate, we might see more of meteotsunamis popping up in the Mediterranean. These ones are triggered by freaky weather conditions and can mess with any coastline that's got a shallow seafloor. They might not be as huge or famous as the earthquakes ones, but they can still cause significant property damage and put people in danger. For instance, in 2006, a meteotsunami struck the harbor of Ciutadella on the Spanish island of Menorca. Yachts were tossed into each other and later stranded on the harbor floor as the water receded, resulting in tens of millions of euros in damage. Unfortunately, meteotsunamis in the Mediterranean tend to be stronger during summer, so if you're planning to spend your vacation in Europe, stay alert for any signs of dangerous waves. If you suddenly encounter a tsunami moving in your direction, remember this is the time to react. Move to higher ground as far inland as possible. Pay special attention to any emergency alerts and information, and follow the guidance of local authorities. Most importantly, do not wait around taking photos. Leave the area as soon as you notice any signs of this danger event, or if you hear an official tsunami warning. Hey, stay safe. Earthquakes are a common thing in Japan. These natural disasters can reach a magnitude 9, where 1 is a light push and 9 can destroy entire cities. This happens because Japan is located on the Pacific Ring of Fire. It's like this. The entire surface of our planet is broken up into about 12 large pieces of the Earth's crust, and they're all moving slowly. In those places where these pieces meet, earthquakes occur most often. Japan is just at the point where the Pacific Plate collides with the plate of the Philippine Sea. This collision happens underwater and creates huge waves, and it could be much worse than just an earthquake. To escape from the water disaster, people built huge walls along the entire northeast coast. Not every earthquake provokes a tsunami. Many tremors occur when the Earth's crust diverges in different directions and creates gaps. It can destroy houses, streets, and forests, but such an underwater earthquake can't cause a tsunami. Huge waves are formed only when seismic activity causes the crust to move vertically up or down. The water pressure shifts at the very bottom, which generates a release of energy. This energy pushes the water and creates a tsunami. By the same principle, you can start little waves when you throw a stone into the water, and such vertical earthquakes often occur off the coast of Japan. First, a wave forms. It's gaining speed and increasing in size. Its height can reach about 40 feet, almost as tall as a 5-story building. It's approaching the coast and accelerating to 500 miles per hour. This is about the cruising speed of a commercial airliner. Millions of gallons of water weighing thousands of tons are getting closer. And now the wave is reaching the shore and demolishing everything in its path. Houses, trees, cars, nothing can withstand the destructive force of nature. A tsunami that was that strong covered the northeast coast of Japan in 2011. It changed the landscape of the beach and the seabed. These changes are the reason for another dangerous natural phenomenon: underwater vortices. Whirlpools draw in everything that is nearby. They used to build dams along the coastline to protect coastal villages, but the wave force easily destroyed these walls. That's why, after the disaster of 2011, they decided to create new large-scale protection in Japan. They spent more than $10 billion in several years on it. As a result, they created about 440 massive walls all along the coast. They combined these sections into one large dam, almost 250 miles long and 45 feet high. The construction is supposed to protect the coast against strong tsunamis, but still, the government has moved some coastal villages to higher terrain. They also ban building anything by the shore. Despite the protection it gives them, many locals aren't happy with the wall. It's a huge problem for the fishing industry. The wall blocks access to the ocean, so ships and boats can't dock at the shore. Some people are unhappy that their windows now face the concrete wall instead of the blue ocean. The money spent on the wall could have been spent on moving even more houses. Residents have concerns the wall only creates an illusion of security. A giant wave can crash into it at great speed and break it into pieces. And these concrete parts can cause even more destruction. Some scientists agree with this opinion. Most experts aren't sure the wall won't give 100% protection, but it can help delay the flood, giving people more time to evacuate. In such situations, every minute counts. It's impossible to predict the earthquake occurrence accurately, but when it starts, the sensors can calculate how much time it would take for the wave to arrive at the shore. For example, the last time a tsunami warning was given 5 minutes after the earthquake. Any big wave is moving at great speed and may be very close to the shore. It seems people almost don't have time to save themselves from a tsunami. Fortunately, the citizens of Japan are ready for this. They regularly take part in tsunami evacuation drills. They learn how to act correctly during a coming flood. They have a plan of action that can save their lives. All that, along with a wall, increases the chances of surviving a catastrophe. Not only tsunamis are formed around the shores of Japan, the power of water here often meets the power of fire. In 2010, a few hundred miles south of Tokyo, near the island of Iwo Jima, a heavy, low rumble came from the depth of the sea. Then 1 million bubbles moved to the surface. The water started heating up and boiling. Its temperature was so hot that you could poach eggs in it. The hot area grew to the size of a stadium. All this was accompanied by a huge amount of superheated steam filling all the air around. Then pieces of soil came out from the water. At this point, it was all over. The water cooled down, the ocean surface became calm again. On that day, an underwater volcano erupted. No catastrophe occurred, but in 2021, this happened again. Japan's Coast Guard warned of strong volcanic activity in the region. Hot steam and gases from the volcano's mouth burst out of the water and rose into the air to a height of 10 miles, which is about twice as high as the top of Mount Everest. A huge volcano woke up and began to rise slowly from the surface. If you look at this place from above, you can see that it's not just a volcano, it's a whole island shaped like a horseshoe. Seismologists say this volcanic island is just the tip of the iceberg, as they mix their metaphors. There is still a lot of volcanic space under the water. The island fills the air with gas and ash. The sky turns gray. Scientists continue to monitor the volcano, but they don't know what consequences this may lead to. Such eruptions of underwater volcanoes are not uncommon off the coast of Japan, but the event itself is unique. Underwater volcanoes don't explode and don't release lava flows upwards. A huge amount of water above them creates high pressure. As soon as the magma gets out, the water immediately presses it to the seabed. Millions of gallons of lava sink, cool down, and solidify around the volcano. This lava forms a thick layer of Earth's rock. Most underwater eruptions don't cause any changes on the ocean surface, but to make an island appear on the surface, a volcano needs a lot of magma. The next volcanic eruption creates another thick layer of it. Millions of years pass, and flows of lava form mountains. Constant eruptions increase the seabed height. Layer by layer, the cooled lava rises higher and higher, and then one day, it appears on the surface and turns into an island. So, in 2013, a small piece of land appeared next to an existing island. Emerging from the water, the volcano began to grow slowly and eventually connected with the island. The area of this island increased by 12 times after 2 years. Vapor is always pouring out of this island, and its surface is filled with super hot lava flows. The volcano behaves unstable, and nobody knows when it's going to calm down. Once, people built a small town on a similar island. This place still exists today. It's located south of Tokyo and is called Aogashima. People are not too worried about the possibility of a catastrophe, despite the fact the last time a volcano erupted here was in May 1785. I wasn't around then. By that time, people had already built a city and lived there. Then, one sunny day, thousands of birds suddenly took off and left the island. Then the ground began to shake. A heavy, low sound came from the island depths. Streams of gas rushed from the top of the overgrown forest volcano. The volcano threw dirt and large stones into the sky. The eruption wasn't quick. It lasted several weeks. More than 200 years have passed since then, and the volcano is still sleeping. They rebuilt the city. Now this place looks like a dream. That's probably the reason why people don't want to leave it. Despite the risk of a new eruption, they continue to live and work here. There are many thermal springs. The island also has rich soil, and the waters around are full of fish. The volcano may wake up at any moment. Fortunately, meteorological and seismological services monitor the volcano activity. So, any guesses? Now, forget about the Kraken and monsters from the deep. I know, it's hard, but try. And you can forget about the Bermuda Triangle and other marine anomalies. They are nothing compared to rogue waves. Giant walls of water that suddenly appear and just as suddenly disappear on the sea surface. The destructive power of this phenomenon remained a mystery to humankind for a long time, but it appears that scientists have solved this secret. A rogue wave is a wave that exceeds at least twice all the surrounding waves. If you imagine the world ocean like a video game, then ordinary waves are your opponents. But the rogue one is a super boss. For centuries, hundreds and thousands of ships have gone missing during their voyages. People have made up a lot of legends about what was the cause of marine disasters. Sea monsters, underwater anomalies, mermaids? But today, scientists are increasingly inclined to believe that rogue waves are the main cause of unusual shipwrecks and missing ships. Some believe sailors' stories about anomaly waves, while others didn't. But no one could prove their existence. However, everything changed in 1995. When a giant wall of water 85 feet high collapsed on an oil production platform off the coast of Norway. The waves around this monster were 39 feet high. In other words, the monster wave was about the size of a 9-story building, and the neighboring ones measured about 4 floors high. The oil platform wasn't destroyed, but the wave showed it could cause considerable damage to any buildings. Immediately after that, people began to study the phenomenon of rogue waves. However, in the beginning, instead of answers, scientists got even more questions. So, what's so mysterious about this phenomenon? We know how ordinary waves work. What's the problem with finding out the nature of rogue ones? Well, in fact, the difference between them is huge. Ordinary coastal waves are very predictable. They form because of the wind and the uneven landscape of the seabed. Depending on the depth, terrain, distance to the shore, and wind strength, the size and speed of the wave increase. These waves are safe. If they're not big, you can surf. If they are big, then you'll see them in advance and run out of the water, like me. Rogue ones, unfortunately, are almost unpredictable. They can appear suddenly, even during a calm sea. They appear not only on the coastline, but also in the open ocean, like a high-water cliff. The conditions for the appearance of these monsters are very chaotic. When several waves combine their energy into one, it creates a rogue wave. But this process cannot be predetermined or predicted. How is this energy formed? How is it released? And how much of this energy is needed? The questions are too complicated. Now, to try to figure it out, you can place a special buoy with sensors that scan wave data in the water. Then, you need to wait for the rogue wave to appear. And you don't know if it's going to happen or not. Fortunately, it happened off the coast of Vancouver Island. This monster, which was named the Ukulele wave, was 3 times the size of the surrounding waves and had a height of 58 feet. Proportionately, it was one of the most gigantic rogue waves ever recorded. And do you think that buoy with sensors helped to determine the nature of rogue waves? Of course not. It just showed the wave's data. In order to solve the mystery, a group of scientists from the University of Melbourne went to Antarctica, and this time they managed to find something. They brought the most modern equipment for studying weather conditions in water. They installed powerful stereo cameras on the icebreaker SA Augelas II and obtained three-dimensional images of the ocean surface. Now, observations showed that the formation of rogue waves began when small waves were most susceptible to wind. That is, waves of varied sizes and directions meet the wind, which makes several small waves combine with one large one. It grows faster using this received energy. This is not just a combination of waves, but also their physical effect on one another. Scientists call this nonlinear effects. To get closer to the solution, the scientists also used the fourth-order Stokes theory, which speaks about more complex interactions of waves and their energy accumulation. The theory didn't help much, but it made the whole study more strange. Scientists realized that small waves fed off one another. Then some waves became bigger than the rest and took away all the energy. This process is called modulation instability, and it explains why rogue waves appear so suddenly, as if out of nowhere. Still, scientists admit that even this information isn't enough for them to fully explain these giant waves. Now, long story short, oops, too late, the wind pushes younger waves together, causing them to grow higher and increasing their speed. One wave steals the energy from the rest, and boom! A giant rogue wave appears, looking disproportionately huge compared to the others. It hits a boat, an oil rig, or the surface of the ocean and spills out all that energy. And that's it, silence again. The existence of such a phenomenon has convinced scientists that rogue waves are the cause of many shipwrecks at sea. Now, seriously, think for yourself. When a ship gets into a storm, the captain reports it by radio and makes records in the logbook. But when a ship suddenly disappears from radar without any warnings about harsh weather, then it might have met a giant rogue wave. They're not tied to any particular location. They are sudden and unpredictable, and this makes them some of the greatest dangers in the ocean. So, what do we do now? How can ships, beaches, and oil production stations be protected? How to predict the appearance of a wave? Well, the answer is crest-trough correlation. It sounds incredibly difficult, but it's actually simple. The highest part of the wave is the crest. The lowest part of the wave is the trough. The idea is to measure how closely the ridges relate to the troughs. With strong correlation, waves form in dense groups. There are several regular waves and one or two large ones in the center. These conditions are ideal for the appearance of a rogue wave. Now, it seems obvious that scientists should use some instruments to measure the troughs and crests on the waves. It seems quite complicated, but in fact, these crest-to-trough correlations can be studied by watching the weather and currents. Scientists hope that they'll be able to predict the appearance of rogue waves using the same systems they need to predict the weather. So, you can take a breath. It seems we're safe. Or not. Given how the weather of our planet is changing, scientists expect an increase in wave height in the North Pacific Ocean. This will contribute to the appearance of giant rogue waves, even bigger than the ones people observed off the coast of Norway. How much bigger? 1.5 times? 2 and 3 times? Well, you better sit down. Scientists conducted experimental studies and found out that these waves can get 4 times larger than previously thought. Could the 85-foot-high wave recorded in 1995 be 4 times taller? It's hard to believe, but let's just imagine it theoretically. A rogue wave with a height of 340 feet may appear in the middle of a storm. This is more than the height of the Statue of Liberty from the pedestal to the tip of the torch. Such a giant wave can pull any ship underwater in a second and easily destroy an oil station. It can throw the Kraken or Megalodon out of the ocean like a stuffed toy. But how is it different from a tsunami? Well, a tsunami is born during seismic activity at the seabed. Such a wave grows, gains speed, and then crashes onto the shore. It's predictable, and you can spot it from afar. So, let's hope that scientists will be able to predict the appearance of rogue waves in advance and warn ships not to sail into the risk zone. Ordinary people who live in coastal towns and relax on the beach are also at risk. In the future, they'll have to look not only at the weather forecast, but also at the risk of giant waves. In November 2020, something terrifying happened in the ocean near British Columbia. Out of nowhere, a massive wave, as tall as a 4-story building, rose up and tossed a lonely little buoy way up in the air. Scientists later confirmed that it was the most extreme rogue wave ever recorded. Such a wave is so rare that experts think that something like that might only happen once every 1,300 years. Interestingly, if that buoy hadn't been floating there at just the right time, we might have never known this wave even happened. For a long time, people thought rogue waves were just sailor stories, something like scary tales passed around on ships. But in 1995, everything changed. On New Year's Day, a monstrosity of a wave 85 feet tall slammed into an oil platform off the coast of Norway. Scientists were shocked, since their models had never predicted a wave that big. That wave became known as the Doppler wave, and that was the first proof that rogue waves were real. Since then, scientists have spotted more of those giant waves, even in lakes. The one near a place called Ucluelet on Vancouver Island was special, not because it was the tallest, but because it was lots bigger than the waves around it. You see, to be called a rogue wave, a wave has to be more than twice as tall as the ones nearby. The Doppler wave was about twice the height of the other waves around it. But the Ucluelet wave? It was nearly 3 times taller than its neighbors. When scientists said this made it probably the most extreme rogue wave ever recorded. Now imagine a huge wall of water suddenly rising in the middle of a calm sea. That's the kind of ocean drama we're talking about. Very few rogue waves have ever been seen with human eyes, especially not ones that extreme. Scientists are still trying to understand how these monster waves form so that they can get better at predicting them before they strike. To do that, they track rogue waves in real time and run computer models to see how wind and water team up to create such powerful surges. Now, the giant wave off Ucluelet was picked up by a special buoy floating offshore. That buoy wasn't alone. It was part of a whole network placed out at sea by a research group called Marine Labs. Their goal is to learn more about the dangerous surprises the deep ocean can throw at us. Even when rogue waves happen far from land, they're still a serious threat. They can smash into ships, damage offshore wind farms, or wreck oil rigs. And if they come close enough to the coast, they can easily put people at the beach in danger. Like it happened in April 2025 in Australia. Thankfully, the Ucluelet wave didn't hurt anyone, and neither did the famous Doppler wave before it. But other rogue waves haven't been so harmless. Back in the 1970s, some ships vanished without a trace. And now, scientists think freak waves might have been to blame. Bits of wreckage were sometimes found later. They were torn apart as if struck by a massive wall of water. Scientists think we could see more of these waves in the future, and this prediction is quite alarming. A 2020 study predicted that wave heights in the North Pacific might rise as the climate continues to change. That means the Ucluelet wave's record might not last as long as once expected. To make things even more intense, new research suggests these waves can be up to 4 times taller than scientists used to believe. And honestly, it sounds terrifying. Imagine sailing in the middle of the ocean and seeing a sky-high wall of water rising out of nowhere in front of your eyes. And rogue waves appear just like that, unexpectedly, unpredictably in the open ocean. While there's no exact size that makes a wave a rogue wave, they've been measured anywhere from 26 feet, like a 2-story house, to more than 80 feet tall. These waves are super steep, have sharp, towering peaks, and can be strong enough to damage ships or oil rigs. But what causes them? That's where it gets tricky. There isn't just one thing that makes a rogue wave happen. They can form when different wave systems crash into each other. Think of it like a bunch of waves from different directions suddenly lining up just right, and boom! They combined into one huge wave that's way taller than usual. Other things can help too, like fast ocean currents, strong shifting winds, or certain underwater features like reefs or deep channels. Those can force waves into a small space, making them stack up. And still, when scientists know all these ingredients, rogue waves are still super rare and really hard to predict. Rogue waves aren't the same as tidal waves or tsunamis. Even though rogue waves can be just as dangerous, they occur for different reasons. Tidal waves happen because the moon and sun pull on Earth's water, making oceans rise and fall. Tsunamis happen when earthquakes, volcanoes, or big underwater landslides push giant waves across the ocean. Rogue waves, on the other hand, suddenly show up out of nowhere in the open sea. Big ships and oil rigs are built to handle waves up to about 50 feet tall. But rogue waves often get even bigger than that. That's why they can cause a lot of damage. For example, in December 2022, a huge rogue wave slammed into the cruise ship Viking Polaris near Antarctica. It broke windows, hurt some people, and sadly, even led to the loss of one life. Rogue waves have caused other accidents too. That's how dangerous they really are. These days, scientists know for sure that such waves happen way more often than you can imagine. I'm talking about one rogue wave for every 10,000 normal waves. Studies also show that waves have been getting bigger over the years. Still, rogue waves are tough to predict because we don't have enough information and they come up so fast. Now, even though rogue waves occur in the oceans all around the world, some places get more of them. One is near South Africa, where a strong current called the Agulhas flows. Another is the North Atlantic Ocean, where big currents like the Gulf Stream meet. Rogue waves have also been spotted in parts of the South Atlantic, Indian, and Pacific Oceans. But even if you live far away from those places, don't relax just yet. Rogue waves can happen in big lakes too. A famous example is the SS Edmund Fitzgerald, a giant iron ore freighter that sank in Lake Superior during a storm in 1975. The lives of all 29 crew members were lost, and a rogue wave might have caused the ship to sink. And that's not the only disaster caused by a rogue wave. Before scientists started measuring these waves, many shipwrecks had been mysteries. Now, some experts believe rogue waves caused some of them. For example, the USS Cyclops disappeared in 1918. The culprit could have been a rogue wave. Other ships, like the Norwegian tanker Wilstar in 1974 and the German freighter MS München in 1978, were hit by huge waves too. The Andrea Gale, a fishing boat lost in 1991, was probably sunk by a rogue wave too. Even modern cruise ships have been hit by giant waves. Rogue waves are, and were, quite popular among artists too. The famous Japanese artwork, Under the Wave off Kanagawa, shows a huge wave that many people think is a tsunami. But experts think it might actually be a rogue wave caused by wind. Rogue waves also appear in movies. For example, take the 2006 movie Poseidon. In it, a giant rogue wave hits a luxury cruise liner, which is making a transatlantic crossing. And as we see, it's something strange, unexpected, and way more mysterious than any other wave caused by the ground shaking. A 4-story wall of water that only rises once in 1,300 years was recorded off the west coast of Canada. Some people blame waves like this for disappearances in the Bermuda Triangle. Rogue waves can get strong enough to sink container ships and oil rigs. The Canadian water monster didn't hurt anyone, but it did become a sensation. And it looks like we're about to see even higher and more powerful rogue waves in the future. The team of Marine Labs, the company that operates the buoy that got caught in the Ucluelet wave, couldn't believe the data they saw. A huge force came out of the blue, pulled the buoy down, and then set it up to a peak before taking it even deeper. They thought it must be a rogue wave, so they sent the data to a scientist at the University of Victoria who specializes in these beauties. They analyzed the data and confirmed it was indeed not a technical mistake. The wave officially became the most extreme rogue wave ever officially recorded as it was 3 times the height of waves around it. Scientists have reported seeing giant waves coming out of the blue for centuries, but no one really believed them. Back in 1826, a French scientist and naval officer was crossing the Indian Ocean on his ship, the Astrolabe. They got in a terrible storm and saw several waves over 98 feet tall. It's almost as tall as a 10-story building. The crew lost one of its members, but the 4 of them, including the captain, made it to land and shared what they saw. But back then, scientists were sure waves couldn't be taller than 30 feet. Everyone took their story as a tall tale. Pun intentional. Over a century later, a cargo ship, the MS München, mysteriously disappeared. People believed it to be unsinkable, just like the Titanic, so it was a real shock that all that was left of it was one lifeboat. When experts analyzed the damage, they concluded that it must have been hit by a wave that was around 65 feet high. Witnesses shared many other stories of giant waves coming out of nowhere, but scientists officially recognized the first rogue wave only in 1995. It went down in history as the Doppler wave, or the New Year's wave. This monster on the North Sea that was 84 feet tall hit the Norwegian gas platform Doppler on New Year's Day. It was twice larger than the wave surrounding it. The rig was built to withstand waves up to 64 feet tall and had the most advanced sensors for its time. The wave wasn't like any other type of wave they'd studied before. So they had to admit rogue waves were real and gave them an official definition. It's a wave more than twice as tall as others around it. It can pop up lightning fast in a stormy sea, or show up out of nowhere in calm waters. These waves have steep sides and a deep trough below, and look like a wall of water rising out of the sea. They're so intense that they can even swallow up rescue helicopters trying to do their job. In 2007, America's National Oceanic and Atmospheric Administration made a list of 50 historical maritime tragedies that were most likely caused by rogue waves. Some of the events on the list happened not in the open water, but in lakes. Lake Superior has something that's got the name Three Sisters. It is a series of 3 large waves, one after another. The second wave covers the ship's decks before the first one is gone. The third wave jumps in and adds extra water. These 3 sisters overload the ship. There's a theory that this phenomenon took down the freighter Edmund Fitzgerald in 1975. There are 2 main theories trying to explain how rogue waves happen. First, we've got the linear addition theory. Imagine waves cruising through the ocean at their own speeds. When these waves cross paths, they team up and become stronger to turn into a rogue wave. Then there's the nonlinear focusing theory. It says waves like to roll in groups, and when they spend time together, they exchange some energy. Sometimes, this energy exchange turns into a rogue wave. To predict the formation of these freaky waves, scientists would need an innovative radar system to keep a constant eye on the waves near a boat. They'd collect all the data and put in a math model that would create a real-time picture of what the ocean surface looks like at that very moment. This model would need to do new calculations of the surface situation every 5 minutes. It would let the crew know if there were any extreme waves coming up in the next several minutes. Such a system doesn't exist yet, but there is a huge progress in this direction. Scientists from the University of Melbourne went on an expedition to Antarctica and found out that strong winds play a big role in the creation of rogue waves. It looks like they're caused by a mix of strong winds and the random way waves move and interact with each other. This idea was tested in labs before, but now they've proven it happens in real oceans too. To study these waves, the scientists use special 3D cameras. These cameras work like human eyes, taking lots of images in a row to create a detailed 3D picture of the ocean surface. It showed that rogue waves happen more often when waves are young, which means they're just starting to form and are more affected by the wind. When strong winds blow over young waves, they make the waves taller, longer, and faster, but not evenly. Some waves steal energy from nearby waves and grow much bigger, which is how rogue waves form. The scientists noticed these giant waves happened about once every 6 hours. They recorded no rogue waves in calmer seas when the wind doesn't have as much influence. Scientists are concerned that rogue waves may happen more often in the future, because there's more energy in the atmosphere and ocean. It looks like rogue waves can be much more powerful than scientists ever thought. They managed to create the famous Doppler wave in a lab for the first time in 2018. This helped them study these mysterious waves up close and showed that their secret is in how they form. We think of waves rolling gently on a beach, but the waves in this study happen in open water when waves from different directions meet. When waves come together from far apart directions, they push the water upward, creating what's called a partially standing wave or a cross wave. This can happen when two seas meet, or when wind directions suddenly change, like during a hurricane. The study found that the bigger the angle between the meeting waves, the taller the cross wave becomes. Normally, when a wave breaks, it forms a white foamy top, and that's where it stops growing. But if a wave is formed by water coming from many directions, it can keep growing even after breaking. These special waves can grow to be twice as steep while breaking, which is already much bigger than normal waves. And if you add up all the growth from waves coming together, they can become 4 times steeper than what anyone thought was possible. This discovery could change the way we build things, like wind turbines or oil platforms in the ocean, to make them safe. Right now, many designs don't fully account for these huge multi-directional waves. Now, they seem to have a lot of similarities, but rogue waves aren't the same as tsunamis. Tsunamis happen when there's a big shift in water, like an earthquake, volcanic eruption, or landslide. They mess with the entire water column. At sea, you might not even notice a tsunami cruising beneath you, but near the shore, as it hits shallow waters, those waves can shoot up to crazy heights. Rogue waves are formed at the surface level, although sometimes they can form deep below, and these are called rogue internal waves. Ocean waves can grow much bigger than we ever thought and be far more dangerous than we realized. People used to believe that waves only moved in 2 dimensions, just up and down, like when you draw them on paper. However, a recent study shows that waves are 3-dimensional structures, able to move in different directions. This finding indicates that the ocean is more complex than we imagined, and today's ships, wind farms, oil rigs, and other structures near the coast might not be ready for what is coming. First things first, waves break. It might seem obvious, but the truth is that we don't fully understand how and why that happens, and don't know all the steps involved. What we do know is that when waves break, they change shape and become steeper. To better understand this process, researchers initially assumed that waves were 2-dimensional. This assumption was necessary because it made it easier to study waves, whether in theory or through computer simulations and experiments. But here's the thing. Saying that waves are 2-dimensional doesn't really capture what ocean waves are like. When most people think about waves, they imagine typical, non-threatening waves you see at the beach. But the ones we're talking about here happen in open water and form when waves coming from all different directions meet up. This wild meeting occurs under certain conditions at the ocean, like in a spot where 2 seas meet, or when winds suddenly change direction, like during a hurricane. When waves from 2 different directions come together, it creates this 3-dimensional wave. To test how these unique waves behave and how they could make the ocean more dangerous for us, 2 researchers built a special tank, like a giant swimming pool, measuring 82 feet wide and 6.5 feet deep. All around this tank, they installed 168 mechanical paddles. These paddles act like giant hands, pushing the water back and forth to create waves, just like you would if you moved your hand through water in a bathtub. Stop the video and go do that right now. No, wait, I'm kidding. Anyways, the paddles can generate waves of varied sizes and shapes. Plus, they absorb incoming waves so that they don't bounce around the pool and mess up the tests. Beneath the tank, they put 28 huge fans that push water across the tank to simulate ocean currents, mimicking how ocean water moves. Altogether, they circulate around 2,400,000 liters of water in the tank. All of this was done to create a kind of mini-ocean, controlled by some really cool technology. Great! Everything was set, and it was time to test. The experiment has shown us that 3-dimensional waves can become twice as steep as two-dimensional waves before breaking. Let me explain. So, the normal waves you see on the beach break when they reach a very steep angle. They have a limit, a maximum steepness, if you will. When that limit is crossed, the wave breaks. So, what this study is telling us is that waves in the open ocean can get as much as 80% steeper than this limit before they start breaking. That also means they can get almost twice as high as normal waves before they start to break. But the researchers found something else that was interesting. Normally, when a wave breaks, it creates a white cap, that foamy part you see on top, and once it breaks, it's done. There's no going back. It's lost its energy. But when these multi-dimensional waves break, there is no white cap. They can only keep growing. That happens because the wave's energy isn't just concentrated in one direction, allowing waves to continue growing even after reaching the steepness limit when they're supposed to break. It's like these three-dimensional waves can redistribute energy and continue building up in the middle of the ocean. That means that together, these waves can grow 4 times steeper and larger than what we previously thought was possible. So, we are talking about bigger, massive waves that can suddenly appear in the middle of the ocean. It sounds scary to say the least. That's why, for our own safety, it's important to understand how this phenomenon occurs. Maybe buildings and homes along the beach aren't at such high risk from this. But these giant waves can pose a bigger threat to things that are in the middle of the sea, like oil rigs, wind farms, and boats. This finding raises significant questions about whether these constructions, as we design them today, are safe and could handle such extreme wave patterns. The thing is, sailors have been trying to warn us about this for centuries. In the 19th century, a French explorer named Jules Dumont d'Urville, I gave it a shot. He reported seeing rogue waves over 100 feet high during his voyages. Even though he was very experienced and respected, plus 3 other people confirmed that it had indeed happened, his story was discredited. Like this account, all other stories about massive and wild waves in the middle of the ocean were dismissed as myths, just tales sailors told to make their adventures sound more exciting. Hey, don't we all? Scientists only started taking these reports seriously in 1995, when a rogue wave was finally measured for the first time. The terrifying event happened at a gas platform in the North Sea, about 100 miles off the coast of Norway. The structure was built to withstand a wave of 64 feet, and even then, they thought a wave that big would only happen once every 10,000 years. But they definitely weren't ready for what happened on New Year's Day, when a monstrous 85-foot wave, 21 feet taller than predicted, hit the platform. In a more recent case from 2018, 8 men were on a 61-foot fishing vessel over 400 miles northeast of Hawaii's Big Island when they suddenly got hit by a pair of rogue waves. One hit the back of the boat and the other slammed into the side. It was too much to handle. A lot of water came over the top, flooding the boat and pulling it down to the depths. The crew had to abandon the ship and get into a lifeboat immediately. Thankfully, they were all rescued with no injuries at all. These are just a few examples showing that our current oil platforms and ships might not be prepared for massive rogue waves. That's why experts suggest that one solution could be for ship designers to make ships strong enough to withstand double the significant wave height. However, they'd probably need some convincing because of the increased costs. So, here is a pretty convincing fact. It's believed that between 2011 and 2018, 210 waves of this type were recorded around the world, but it's very likely that the real number is much higher. What triggers rogue waves is still somewhat of a mystery, but we know they are not caused by movement on the seabed. Instead, they seem to be more related to bad weather. In Tampa Bay, for example, most rogue waves come in from the west, especially when it's stormy or windy. But we can't say this is the main cause everywhere in the world, as experts believe there could be several other factors at play. What is really concerning is that rogue waves can strike without warning. The open sea can be completely calm when suddenly the whole scene turns into a fight for survival. So, can we actually predict this phenomenon? It looks like we can. In a very recent study, researchers created a computer system that uses measurements from buoys to predict unusually large waves 5 minutes before they happen. They can catch about 3 out of 4 rogue waves. While the system does have some false alarms, the researchers say that from a safety standpoint, knowing a rogue wave might happen is better than not knowing. And I think we can all agree on that.